So, good morning, everybody, on this lovely Thursday. We are already on day 9 of our video log for the Timber Tales Definite Edition. And as usual, we would like to process in the normal direction. And for that, don't let us just waste too much time and hop into our codex board. Or the codex planning. So let us go over to the browser and check out, as usual, the Twitch deck from yesterday. So yesterday, Twitch day 8, we loaded another challenge map, which was actually the mushroom map. We placed our first camera view on the left top of the placement zone, and we fixed the off coordinates from the X, and we start with the single unit for placement, which also had involved some animations with the sprite sheets animation for the badger, and we had some coding around that, how to place it, etc. What I would like to do now is to just finish this card, because we have done this. Yes, let's archive it. And then, of course, we are today on day 9. And for today, I have a really cool agenda planned or cool stuff ongoing. Because what we would like to do today is to add a finite state machine for our different states in the game. So what we need is a game state handler, and we need character states for our different animations we created yesterday. And I would like to achieve that with a game state handler and a character state handler, which is based on a finite state machine. And today we will implement that. And I will show you how we can use these different states for having the game running and having a state of the game we are actually can secure in which state we are. We then want, if we are getting this far, if we have these different states, our goal is we would like to click on a placement cell and place our first unit there, our badger. I would also like to add a second unit so that we have a second unit to test around with and we can make better classes for it. So that's the plan for today. Let us hop into some project planning for today. We have, as usual, 10 to 12 minutes left for that. I created yesterday a refactoring card, which is just a hero card for tasks to refactor. And this I would like to refactor the tile creation process, where make use of the position component, which is Godot actually providing us. And I have done this already yesterday. I will show you that later on. And the mapgd script is also a refactoring task I have added yesterday, because I think in our map there's actually too much stuff ongoing right now, and we should do less in the map and extract some more code out of it. We maybe can do this today as well. But let us continue checking the challenge map. We have the add game state handler, we have the add map objective. So let us just do some more planning. As we said for today, I would like to have character states. Character states. With the character states, we would like to have having a state machine inside the unit for handling the different states of the unit. Attack, idle, move, death. These are the states we have at the moment. So let us just save this. And the effort is by 2. Medium, it's coding, it's for me. Then we go back to our other cards. Then we would like to add the game state handler. Add state game handler. This is the state machine for the game. So what we need is, these are two different things. We need the state machine for game, and we also need the states for game. So the first one is the machine which handles the states, and these are the states. We need different states for the game to know where we are at. And these states can be something like placement, something like turn player A, something like turn player B, something like map event happening, something like that. So it can be the game can be in different states, and for the different states we need to adjust them accordingly. So yeah, I have to break a little bit. I'm sorry for a minute. I'm back soon. So sorry, I'm back. I am back. So let us go on here. So we have the states for the game, and I would also like to check out how states were handled in the original version. That I would also like to do. So then this is also what is going on here. Yeah. This is also efforts is 2. It's medium. It's for me. It's coding. We go to the hero card. So for today, I would like to add with the states. I would like to start with the state machine for the game. We would also have to use a state machine for the character. So we need another subcard, state machine, character. This is most likely the same like for the map. Implement a state machine for the units to handle each state. It's pretty simple. I think if we have done the map, this one will be quite easy. But we just need to make sure we have it there. So for today, my plan would be to add the character states, the states for the game, the state machine for the game, and the state machine for the character. And afterwards, we can improve the viewport placement. I had an idea yesterday how to get it. We can add just idea. Take the distance between first cell and last cell and calculate the middle point to position the camera there. One thing left to do then is to adjust the zoom that every cell is in viewport. So for yesterday we placed the viewport for the camera on the placement zone, and I have just placed it to the top left of the placement zone, and what I would like to have is to place it in the middle of it and adjust the zoom accordingly. So maybe we can do this as well for today. So I think this is what we would like to do. Let me just check what we have into the tile map. Here we are done. We had the placement zones. We need to fetch the placement zones out of the JSON. What I don't see why it's not a card like that. And it's done already. Tile map data layer. Also effort 2. Coding. There we need some stuff still to do because we need the accessible variable, and there are also more things following. So this one is not done for now, but this is a work in progress, I would say. So for today and for now, I think we have a lot to do. Let me check my hand. There's nothing in. So let us just for today say I would like to start with the character states. I would like to enter focus mode, start working on it. I'm not sure if I need to do it all the time. Or how to do just to start them, yeah. I would say this is how it works. So we just need to start all of them. Normally I just like to just work on one card, but in this case we have all 4 on our hand, and we can just work with our hand and go out of the decks and have a better focus viewed for us and for me what to do. So this is the first thing we would like to do. Then we would like to do the second thing and the third thing. But we have still 2 minutes left. I would like to go to the game design document and just review what we have written yesterday. I have written the core loop with the summary, and we had the elevator page and the unique selling points, which are quite nice. What I would like to add is the target platform. It's PC Steam. And what I would like to add, I just show you something on my Confluence, on my old Confluence. There I had the templates, and there I had the game design templates. And let me just see, we have the design pillars, we have the features, interface, art style. Yeah, I would take it into account, the art style. Modern approach with vector-based graphics. Dark and fearsome atmosphere. Clean colors. Simple shadow and highlight colors. Easy shapes. Spine for animations. Yeah, I would just say it. So as you can see, it's always what I try to do is to just write down a little bit every day, so we can actually fill it out one day. It's a little bit sloppy right now because I haven't documented too much at the moment. But we have so much to do and we have so few time. How is it called? So less time. Wenig Zeit. Little time. So little time for getting done everything, because the problem is we need to code, we need to project plan. I would like to show you things and stuff like that. So let's go into too much detail. Let's shoot up Godot, start a game, and then start our first ticket to get actually stuff done. We go to our hand, not on the decks. We want to create our state machine for the character. And no, state machine. I would like to start with the states. So states with the game, states with the character, and afterwards state with machine for the game and state machine for the character. So this is the right order. So what I would like to start with is check out how states were handled in the original version. For this, we need to start up my Android Studio because it's on the old project. It's in the JS project. So it was a Node.js server in the old place. And now we have to look a little bit to find it because I need to check it out. This is the data storage. This is the admin storage. This is the map editor. These are my modules. So we have somewhere the game server. For the game server, we have a message queue, which is just handling. We have a pre-check handler. The game pre-check handler was doing queue player mode, modes arena, get army, callback. And we have also a queue message handler. Okay, that's not so interesting. So what we can see already in the pre-check handler is that it has the function is valid and it was checking if the player queue mode was arena and was ranked. So what we are looking at here is how two players were matched together in the old code. So as we had a multiplayer there, this is what this server was for. So that is actually not the right thing we are looking for. What we are looking for is actually the game handler. I think it's that one. And the game handler was handling the game with the disconnection of the player, sending game data, report error, start mission, etc. And I think where we should start is create game. Or start. We have create game and we have create mission. The difference between these two functions is the create mission was the solo campaign or the challenge mode, and the create game was the multiplayer mode. So we can ignore the create game because we are now in a solo player environment. And we can also ignore the missions because we are now in the challenge mode. That is what we would like to implement in our new version. So let us see. The mission was a game mission. So maybe we also can open the game mission. You can find the declaration here. We need to check it up later. And we had start mission. And let's search for it. Start mission. There's the start mission. So the start mission was getting the mission map. It sets the player to the mission. It sets the map to the mission. It registered all the game events and we pushed the mission. Then we had a player emitter who said player emitter on army loaded mission start placement. Okay, so what we are missing in our new version right now, or in the Godot version, is this whole stuff of the army loaded. The army loaded was in the original Timber Tales. I planned that you draft your army together, so you had the possibility to draw units out of collection and you pick up, maybe you had something like 1000 points and each unit has some cost to bring it to the mission, and then you had to draw your army together, and then you save it and you start the mission. And this is what the army loaded emitter was for. It was just saying, okay, our army is set and is loaded. We need to at least prototype it in the new version as well, because we need some kind of army, some kind of units we would like to draw or we would do with the placement. But for now, it's not that important, because we now just go on to the mission and let's look what we are doing in the start placement. I think this is where the magic happening for our first state and where we should look into it. For that, we need to find out what the mission is, and I already think the mission is the game mission, and the game mission is under campaign game mission. So we need this one. This is the game mission. And here you can see already in the mission we have 3 different states, and this is where we would like to look at today. These are our game states. The first game state is created, which was actually the initial state, which is triggered or handled when the map is loaded and everything is fine. Then we enter the placement state, which is actually the placement of our units, where we can then place the units on the map tiles, and afterwards we enter the state started. And so the mission knows that it is started. As you can see, we also have a check here, which just doing a valid check if the states are of this type. Otherwise, it would say it's a not valid state. We will now we will implement that in a minute also in Godot, so stay tuned. What we then have is we have the game mission. In the mission, there are 2 teams available. It's the red team and the blue team. We as player are always in the red team, and our enemy is always the blue team. We then check if the mission ID is challenge mode, and we have challenge mode because we are in the challenge maps. And what we are doing then is we're creating a new challenge, and then we're having the AI team. This available teams, splice, random. Okay, what I'm doing here, I've said that we are always the red team and the player is always the red and the AI is always the blue. That isn't right. What I'm doing here is I just do a random, and so the player can also be blue. But this is, yeah, I don't know why I've done it in this way. Yeah, I have no idea why. Maybe to give it more a random state that you can also start on the other side of the map, because otherwise we always would be on the same side. And if we change it up with red and blue team, we maybe can have a little bit more variance in the starting point, and then maybe the map is a little bit more fun to play on the other way around or from the other side. I think this is the idea behind it. But nevertheless, what we would like to see is the challenge. The challenge is campaign challenge. Campaign.challenge. In the campaign.challenge. Campaign. I'm a little bit confused right now because it's saying ... require campaign and then challenge. Ah, this one. No, this is challenge creator. This is challenge handler. This is challenge model. Where's the challenge actually? We are in the game mission. This one. So I would expect it to be in the same order. Same. I don't understand why it's not why it's not here. So let me just do a search for it. Challenge. campaign challenges. Challenge. Okay, so I am a little bit confused with the require here because it should be in the challenges. And I don't understand why he is having it in the campaign. And even in the campaign require, I can't even find the campaign as there. Okay, I pick it out from here in the challenge. Here is mission. Yeah, it's old code. Here's the challenge. I'm sorry. This is not right. This one is right. The code is pretty old and I haven't looked at it a long time, but I know that I have written some great stuff here because I invested a lot into this server, and I think also the structure of the server is quite complex, but it's really good, I would say. Not to reward myself too much, but there was a lot of thinking ongoing in the server and in the backend in general for all this game. So I think it's definitely worth to look into it, how we have done it, because there is, yeah, as I said, a lot of thinking ongoing or was ongoing for this. And I think it's a quite good server and it's quite good code for that. So it makes sense to copy a little bit. So what we would like to know is the challenge. So what we create here is a new challenge mission, and this consists of a mission call, which is just mission call. It's just the constructor of the mission, and it just says it's a challenge, and then we set the points to 1000. This is for the army, as I have said. Then we have an X and Epsilon coordinate. We had that. That's just for the visualization of the mission map, which is not needed here. Then we add a new AI, and then we add two objectives, how we can win the challenge actually. And it's the objective finish placement. We need this to finish the placement, and then we need to kill the base of the enemy, or we need to kill all units. These are the two winning conditions. So then we have drafted units, which is just an empty array, and then we set the player, the AI player, to a new player which named AI. So afterwards we extend the challenge a little bit with prototyping here, and there you can see we have a different difficult level of the AI. We have a different level which we set here, and a different map. We create the AI units. We can look into this in a moment. We have the AI team where we actually set his team. We have picked further, and then we just set that. And here we create, for example, the AI units. As I said before, we had in a challenge something like 1000 points to create an army. And on level 1, I have given the AI just an army of 800 points to make it easy. If we are on level 2 or 4, he gets 900 points. And if we are on the max level, or yeah, better said, on what can we have? We can have 1, 2, 3. So I have no idea why I've just done it with case 2 and 4. So what I would expect is also that 3 would go to 900 points. And otherwise, if we are over level 4, he also gets the 1000 points from the from the player. I'll just leave it in the original way. And if we are over level 7, he gets more points with each level to become more and more difficult to beat him. Then we had the available races, which are just 2, and we pick a random race. We have the spend points. We have then the unit lists we get. We're taking the spend points and we just take random units and we roll as long as possible as all the points the AI has are spent. And then we finally get the placement zone, and for each drafted unit, we try to place it on the place on the map, and afterwards we would remove the cell from the placement zone. So this is what we are doing in the challenge mode. So so let me just think about it. it's not relevant for us now. Not now, not at the moment, because for the state machine, it makes no difference because the AI needs to be loaded in any case as our enemy. So what we could do is we could go back to DEX, we could go back to the map, we could go over there and we can just say create enemy army and place enemy army. So we would add 2 tickets here. Draw units for our AI enemy for the challenge map. Oh, we can just do it with coding. It's this, and we can place after drawing the army for the AI. We need to place it on the enemy placement zone. And that is also, yeah, it's 2. What is this? Hello? 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 I was there. How could I go over there? Medium coding over there. So this is what I just want to do really fast. So this is what we have seen in our code from the old code, and this is what we need to do. But let us go back to the states. What we actually want to know for now is how the states worked in the game. So we go back to the game mission and check out the game mission. I take another zip. And we had the different mission states. What we can do actually is we can go over the modules and search for states. And then we could check if we find the other states we also have. So what we first have is the mission states. This is created, placement, and started. And then we have the challenge states, which also are the same. And do we have more? No, that's everything we have there. Okay. So I have to leave you for another minute. I'm sorry. So I'm just put more wood in the oven to keep the fire alive and to keep it warm right here. So finally we are back. So we have just these 3 states, and I would like to work with these 3 states for the moment to just making some progress in the Godot. So let us go to Godot. Let us just remove a little bit of stuff here. Okay, I should have done this before, and afterwards we say all. So what I would like to do is I would like to create a new folder. Which is called Finite State Machine. Then I would like to have a new folder, which is states. Then I would like to have a new script, which is state. And then I would like to edit it. So what I would like to add is class name and is the state. So our class name is state. And I would like to have a function, which is enter. I would like to have a function which is exit, and I would like to have a function which is update. So this is a pretty simple state which just have 3 methods: enter, exit, and update. Then I would like to have a new script which is our game state. So we have also a GD script there. It extends from state. And I would also say the class name is game state. And then we have nothing else for now. Let me just think about it. I just doing some pretty easy prototyping right now. So we need to see how everything is fitting together. So I would also like to add the character states, which is also extending from the states. And then we have also the class name character state. So what we have done so far is a state with the 3 skeleton method, enter, exit, and update. And then we have a game state, which is extending from the state. And we have a character state, which is also extending from the state. This is what we would like to have. What we now would need is some kind of available states or something like that. But I think we could do this later. Yeah, I think we can do this later. So let us just create a new folder and we say game. And now, as we have seen in the original code, we have created, placement, and started. I would just take them over right now and just say we have game started state. We have game created state. And we have game placement state. Is this right? Placement created start. Yes. So what we would like to do here is we're extending the game state. And we just don't need to do anything else right now. So these are all game states. Game states, game states, game states. They don't do anything right now. We need to define what we need to do in a minute. I just try to do some skeletons right now. So we do the same for the character. For the character, we also know we have the character. Sorry, I won't like to have. I would like to name it unit state, because character is not right. We need to have the unit state. It's a unit state, and then also we need to delete this one, and we add a new folder which is unit. No, states unit, yes, right. And then we need a new script which is unit move state. We have a new script which is unit idle state. And then we have a new script which is unit attack state. And then we have a script which is unit def state. So why we know this different states for the unit already? Because we have the different animations for it. So let us just go on pretty quickly. What we're doing here is the same as we have done before with the game state. We just extending from the unit state and just removing anything else to just have some skeletons here. And this is done for all 4 unit state. So this is pretty simple, yeah. This just a lot of writing right now. We can just make some progress by just write down a lot. So what I would like to do is, I would now like to start with some animation and with a unit state. And this I would like to start with is the idle state. maybe I think the idle state is one of the easiest one to start with. So we have our badger. We can fire up the scene, I hope. Yeah, unfortunately we can see it right there. So what we are doing right now is we just add a camera. And then we can see our badger. So he's already idling. This is because we have the autoplay on the idle animation. I would like to change it back. And as you can see, he is now just standing still. So what we would like to achieve now is having the badger idling by our state. So let's go back to the script. What we would need for that is we need the enter function. We need to implement the enter function of the state. And what we would like to do here is play idle animation of our unit. So, and what's the problem we right now have? We know that we want to play the idle animation of our unit. And yeah, that's actually it. So what we need for that is we need the unit. And we also need the animation. So we know that the animation is idle from the name, but we also would need the components. So there are now different ways to achieve that. But let us first go back to the character. Character is in game objects. It's the badger. He would need a state machine. So let us add a new node component, which I would call state machine. So what is the state machine? The state machine right now is just a container. And the container will store our different states. So what we would need is also another 2D, and then we would have something like the idle state. Unit idle state. Yeah, I would rename it. It's the unit idle state. And I would like to do a scene out of it. Scene, new folder, states, unit idle state, and we would put the script. We have already a script, which is states unit idle state. This would be the script for it. So we have a state machine and we have the idle state. What we now need in our unit, we now in the badger, we need to have the states processed in some way. We need to pick up the states and then we need to go over them. So let us just check how it's done. I have watched yesterday.
Let's say you're designing an enemy. You want this enemy to wander until it spots something, then chase that target, and if it gets close enough, give it an attack. How would you program this? Call this state machine. Then I'll attach a new script. So the plan is to have the state machine in the scene tree, and every state can just be a child or not. I'll go ahead and track the current state, and then we'll go ahead and define the process and physics process functions. And inside of here, we can check if we have a current state and call update and physics update respectively on the current state to a function that takes in the state that called. We'll call .exit, and then we'll call .enter on the new state dictionary and a state, and then to the transition.
So that's actually how he's done it here. So what we of course need, we need a state machine script. It makes absolutely sense. So let us just save this also as branch, and it's also a state machine scene, and then this is the state machine, this is state machine idle state. Not 2, it's 1. Why can't I rename it to 1? I'm pretty much... I don't care for now. So what we have is the state machine. So, and we need the state machine script as well. So we add a new script and we add it to the scripts, finite state machine, and we say state machine script. So as he stated correctly, we need a current state, which is a state. And then we have the states in a dictionary. So let us just define var current state of type state. And then we have var states, which is a dictionary like that. Yes, of course, like that. So what we then need to do is we then need the ready function, we need the process function. Okay, what he is doing is he is doing it with the process and the update. Okay, I understand. So we need the process function. We get the delta, and then we say if current state, then current state update. And I think we would also need the delta there in the update. So what we are doing is delta, and then we go back into the state, and we would say here we get a delta over there in the update. So Now we have it working. So what he's doing right now in the state machine is he is checking if we have a current state, and then he is processing the state. And he is updating the state. That's also quite cool. But what we need to do is we need also a transition in the ready function. Yeah, so he also has done an initial state where he can already have an initial state, and then he is calling an initial state which is an enter function. We could do this also pretty simple. So what we do is we export a variable with an initial state. This is state. And then we have here an initial state. And then we say in the function ready, if initial state dot enter. And so we enter our state in the first place. So yes, as he is doing that. And of course, and of course the current state is then the initial state. So the state machine knows that we are in this state. So if we're now going back to our badger, we have this state machine here. And what we can do now is we place the idle unit state here. And what we can do now is we can say we would like to have the idle state here, but he only allows us to having the state there. Yeah, the problem I have created is that we extending now from the unit state to make it more unified. The problem is we would like to have two different state machines for the game and the unit, and so maybe I already have taken a step too much to make it possible. Because what we would like to have in our unit state machine is, of course, having the unit state available. And if we are doing that by just the state, yeah, let us just go with the state for now to make it happen. So what we can do now is, hopefully we could add the state. No, we can't. Why we can't add it? Because the unit idle state I've created doesn't. Okay, then maybe it was just a problem with that, and it's also working. Sorry, what I would like to have is the unit idle state here, or the idle state, and then I would like to go back to the idle state and would like to do it back to the unit state, and then we go back to the badger and we say idle state. It's working. Okay, so the problem was I haven't assigned the script to it, and so he wasn't aware of that the unit state is also a state. So this is working as I would like to have it. So what I've done now is I've just added the initial state is the unit idle state from the badger to our state machine. And what this is doing is we now check in the ready function if we have an initial state, and if we do so, we call the enter method, and the current state becomes the initial state. So this is quite nice because we know that we have an initial state, which is the unit idle state, and then we will get the enter function called. The problem we have right now, or still have, is that we don't have in the idle state the access to our unit to actually manipulate the animation. So let us check out how he had done this. I would like to see it. Okay, he's just doing it with the export variables, and then we are just passing them in. Okay, so also there, what we then would need for our idle state is the animated sprite sheet. So let us go into the unit idle state. And what we need there is to export a variable animation sprite, which is the animation sprite animated sprite 2D. Yeah, we need to export it here, and then we can say in the idle state export variable var animation state. Hello. 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 Animation sprite. It's an animated sprite. It's broken. What's up? Ah, what's that? So now it was broken. So what we want to do here is we want to add the animation sprite for this one. And now we can go into the unit idle state, and now we can access the animation sprite and say animation and say play, and then we can say, I think it's called idle. Yeah, it's idle. Cannot find property play on animation. Animation, set animation, string name animation. Let us just look at where we are in animation. It's the string name. Pause is playing, get playing speed, just play. Okay, so we don't need to actually animation, we just can say play. So that is everything our idle state needs to do right now. It just gets the animation sprite from our character, and it's playing the animation idle. So if I've done everything correctly, we can now shoot up the scene, and the idle animation is autoplayed. Because our state machine knows the first state we have is the idle state, and he is just playing the idle state. That is cool. We could now do, just to make the other states working as well, we could do the same for the other states. So what I would like to do is, I would like to add another node to D. I would name it unit move state. I would like to branch it out as a new scene. In the states, it's the unit move scene. I would like to open it right here. I would like to add a new script, a load the script for it. We have the scripts, fitted state machine, state unit. We have the move. Then we have the move state, and this is also needing a variable with animation sprite, which is also an animated sprite 2D. And we also have the function enter, and we would say animation sprite play move. Let's see if this is right. Yeah, it's move. And then we say in the state machine, now we take the move state, and then we fire up the scene, And then he is saying cannot play on null. This is because we need to in the move state also to this to set it. And now we have the move function. And why? Because it was so cool and so fast, we need to do it 2 times more for the unit attack state. And we need to do it for the unit def state. Oh, sorry. We need to do it for a node 2D. And we need to rename it to the unit def state. So these are our 4 different unit states we would like to have. And we have. And we branch them out. Branch them as a scene. Branch them as a scene. We would like to load the script. We would like to no, I think I need to go over here, attack state, then we need to load the scripts, the finite state machine, the states unit. Come on, I guess we can always, so just take the attack state over here, save it, then we have the move state, then we have the def state, we go to the def inspector, then we have the def state. We just put it there, we save it, we go back to the batcher, we just open the def state, and then we also have an export, which is var animation sprite, which is then animated sprite 2D, which has the function enter, and we have the animation sprite play def. Then we go into the attack state where we have to export var animation sprite, which is an animated sprite 2D, which has the function enter, where we say animation sprite play attack, like that. Then we of course assign them to this one, and then we go back to the state machine and we take the attack state, we test the attack state working, and we are testing the def state, and also that is working. So what we have achieved right now is we added a state machine to our batcher and we created 4 different states for it, and soon as we enter these states, we play the different animations for it. And as we have tested them, they already working as a charm, so it's just easy typing. And yeah, it's working like that. So now we have, of course, again, different options where to go on. The first thing I would like to see, or the first thing I dislike a little bit, right now, but I can't tell you if it's a problem in general. But the thing we have 4 different states and they are actually doing all the same. They have just an animation sprite and they just play a different animation. So that's not so cool that we have classes, or better said 4 different scripts which are actually doing the same stuff. But that's because we are just adding the animation for now. We will, of course, for the movement state, for example, we will have to adjust the position for the unit as well, and not only the animation, because to the movement animation there also we require to change the position. So for now I would just let the code in this place, just to have 4 times more or less the same code. We will need maybe to refactor it later or to make it better, because we don't want to have the same code there over there. But yeah, we have to think about that. So what's interesting now? What is interesting now? Or where we go on is the better question. I would say we would like to have a transition. So by this, I would mean, as you can see, we can just do it with the attack animation. We take the attack as the initial state, and if the attack is done, he is ending at the last frame of the attack, and he is just stalking there. And what I would like to have now is I would like to transition back into idle mode once the attack is done. So we go into the attack state and we write the function exit, and then we will work with a signal. We have seen the signal in this video before with the state machine. Base setup, base setup, base setup. I'm sorry, I need to see the state transition. No, that's not correct. That's not correct. That's not right. There, it's transitioned. Okay, so he added a signal which is just on transitioned. So now I understand what he is doing there. So we go into the state and we give the state a signal which is transition. What we're doing then is we go back to the attack state and we say transitioned emit, and we give it self and we give it idle. We don't need to understand that for now. It's just, we just emit the signal and we go in our state machine. And in the state machine, what we need to do is we need to go over the states. This is what here for here it's what here is done. So we need to go over every child in the getChild function. For child in getChild, or getChildren, is it? Yeah, it's the child for in getChildren, and then we look if child is actually a state, and then we say we add the states to the dictionary. So we have our states and we say child name, and we take to lower that we just have a lowercase in it, and we just put a child into it, and then we do the transitioning thing. We connect on child transitioned and we connect, and then we add a function like here on state transitioned. This is our function for it. So then we need a new function which is called on state transitioned. So this is the old state, and there I would suggest we get the new state. Better said, it's the new state name, yeah? So what he's doing there is he's saying if old state is not equal to the current state, then we just return here. It's just a safety method or safety check that we don't transition if the old state isn't the new state, because it could be happen that in the meantime the state was changed and then we don't want to do the transition.
Here as well, just to make sure capital.
So let us again pause, and what we then do is we say the new state is, we try to get the new state out of the state. So the first problem we will get is that the name isn't our name. So what I need to do is in the attack state, it's not idle, it's unit idle state. in this case. So we go back to our state machine and we say var new. That's the names, the new state name. So we say name new state is states get, was right, get new state name to lower. Sorry, to lower. So what this does is it tries to get the new state out of our state machine states and looks if not new state, we just would return here as well. So let us check this out, what he's writing there in the end. So we are saying the new state so what we then call, so what we then have is we have the new state in this case. And what we now would like to do is we would check how he is done if we are having a current state. So if current state, then we need to call the current state exit function before we can then call on the new state the enter function. And this is actually our complete transition we right now have. And if I have done everything right, we could now start with the attack and it should go over to the idle. Let's check it out. It's not working. We are still stuck in there. Then we have to see why. What do you think why it isn't working? I can't. So let us first check if we are getting to the connection. We do. Then let us check if we are getting into a transition. We don't do. Okay. So the problem is in the unit attack state on the exit function. Because, okay. Yeah, of course. Because the exit function is never called. To do this, we would need to define. Oh, wait a second, because the current state, let's check in the state machine, he would say in the current state is the exit. So what he needs to get done is the emit. So let me just check how he is doing it in this example. The current state. Then we have the enemy wandering time, the wandering time update, randomize velocity. That's everything cool. Okay. What we need to do is physics run, enemy follow, first thing. What I'm searching right now for is the code where is emitting. There. Ah, it was there. So he's in the physics update and he's just checking if it's played. Okay, so what we need to do is not to use the exit function. We need to use the update function. So we get an update with the delta, and what I would like to do or would see is if animation sprite not is playing, I would say emit signal transitioned. Now we can just say transitioned emit self and unit idle state. So this is the code actually I would like to test out. And now we are getting here, and as you can see, it's working like a charm. So we have the attack state, and then he's going over into the idle state. after the frame is done. We could now do the same for the movement, but the movement is a little bit more complicated because it's looped. And there we would need to have a position. And that's a little bit more complicated. We will do it in the future, but I think we can't do it for now because therefore we need to having the badger actually on the map placed. Or no, we don't need. No, we can try to do the movement. We can try to do the movement. So let us go into the movement state. What the movement is different from the attack is, the attack is done on the position where the badger is actually starting in. On the move, we would like to move in a specific direction. For that, we would like to need some kind of move speed. I would just have it. We can also check he had move speed something like 40. It's a float value. I don't know what actually this does. Maybe it casts this already. And we also would need some kind of velocity. No, the velocity is the enemy velocity. What we would do is this is the follow code. We would need the wandering state. He somewhere has done the wandering state. This is just what we're doing, but we would like to see the wander state. So what we need is a move direction, which is a vector 2. Move direction, vector 2. And then on the enter function, we could set it. We can also do what he is doing. We can do something like randomize wander. And then we have a function which is randomize wander. And therefore we just do randomize wander. It's the move direction. Move direction is vector 2, of course, vector 2, random float from -1 to 1. And I would guess also a random float from -1 to 1 in the other direction. And then afterwards he say it's normalized. That is our move direction. So I've done this wrong. Too many arguments for rand f. Float rand f from 2. Why it's too many? Oh, it's range, yeah? Yes, sorry. Sorry, it's not rand f, it's rand f range. So as you can see, I am also also depending on looking at tutorials and figuring out how stuff works. And I usually, we can also take a time for now. I also need to look up things and get it working for me, because this is the normal process of development. So copying is always the first place. And if we have stuff like that, which is also working the same time, the same way how our code should work, then it's cool because we can just copy it and look how it works. And afterwards we customize it for ourselves. I will take a short pee break. I'm back in a minute. So, sorry, I'm back. And let us go on. So, let me just finish my point I've done before the break. So, what I would like to say is, don't be scared to copy things in the first place. Because if you don't know how things actually working, all the tutorial stuff on YouTube and stuff like that is worth so much, because you can just take out the code as I have done for now, and you have a starting point. And I think this is quite important because it's always hard to know where to start off. And if you can take out some code snippets from anyone who has done it already, there is no shame in it, and just copy it over to your game and just work with it. Of course, you will later on, if you understand what is doing there, you need to define it in your own way and just don't copy the parts of other game devs, because you need to know what you are actually doing. But it's always a great starting point, and we can go into much more detail later, and we can adjust it to have it more specialized for our game. So what we have done now is we just have taken over the move direction, which is random, and we have taken a random time where it's going. So what we now need to do is we have randomized it, and now we need to implement also the update function here with the delta to make the badger actually moving. So as you can see in the update, he is just saying, if the wander time is greater than 0, then we will remove the delta out of it. So it's pretty simple. We say if time is bigger than 0, then we remove the time by the delta we get. And then we could say else we could again randomize it. We could, but I'm not sure if we want to do it, because then we have another question. We don't know when we are finished with the moving actually. Yeah, so now we have another thing. We need the physics update for the movement, because we haven't had a physics update yet. And therefore we need to go back into the state, and we need to pass another function here, which is func physics update, and that one will also get delta, and we pass it. And in our in our state machine, we then of course need to have the physics process delta, and also there we have to say if there is a current state, our current state needs to update the physics as well with the delta. So in the physics update, in the movement now, we implement the physics. No, that's not the right one. We want the physics update. I'm sorry, this one. And we get the delta there. And there we would like to do as he is doing. We look if we have actually the enemy and the body. Actually, we would like to move. In our case, it would also be the animated sprite for now. And therefore, we would say the animated sprite we don't have a velocity. Yeah, that's the problem, because it's not a character body for now, and we don't have the physics working with that, and so we can't actually move on the direction and the velocity. So for that, we need to rearrange our badger unit, because we would need a character body 2D. Yeah, we would need to have a character body to actually make it work, and we don't have that. So what we instead would like to do, or I would like to do, is to work with the position. And the position is then the move direction multiplied by the movement speed. Okay, this wouldn't work. This will not work. So what we need to do in our case is we would need to look if we make it easy to just have check it. We would say if animation sprite position X is smaller than 1, then we would say the position is just the X position is just added by X. So we wouldn't need this one for now, and we wouldn't need the move direction because we have no character, and we wouldn't need the movement speed, and we wouldn't need that for now because we make things more easy for us. And therefore we just do a physics update, which is just moving our position. And then we say if this position is achieved, we then do emit our transition of ourself, and then we say unit idle state. So let us check that out pretty quickly. We have the movement state as our initial state, and that was a little bit too short. Let us take 100. He's moving pretty slow, so let us increase it. So as you can see now, we have now a moving, which is actually moving to the X position of 100 by 1 step at a time, by 1 pixel. And once we are there, we have the emit of the idle state, and we say our moving is done. And then we can again go back into the idle state. So this is how the transitionings between these states are working. And yeah, let's see what we would like to go on. We have half an hour left, which is pretty cool. So I would say for now we can't do much more in the unit states, because the unit states are pretty much working with the different animations. We have the movement, we have the attack. As I said, we need to define them later in more detail. For now, we can just secure that everything is working as we would like to have it in this way. So let us go on with the game state machine. Also, the state machine itself, we can just take a quick look over it, is pretty much now very, very abstract. So we can actually use the same state machine for our map. So let us go over there. We will again close a lot of stuff. And then we go to the assets, we go to the game time map, and we go to the map. And then we have the map opened, and in the map I would now add the state machine. And now we would need, as we have done before, the different states. For that we create a node 2D and we duplicate them, and then we say we go here into the states of the game we have, and then we say it's the game created state, and then we say it's the game placement state, And then we have the game started state. Therefore, again, we're creating branches out of them all. So it's the same step all over again. And we also have this one. So then we go into the game created state and we put in the game created state script, inspector, so game created state. We save it. Then we go into the placement state. There we put in the placement state, save it. Then we go into the game started state and we put in the started state script, and also that we save. And now we can go back to the map and work with the different states. Also here we have the state machine, and now the statement needs to have the create state as a first initial state. What this is doing is we get the create state on the function enter. And now we are entering the created state. The created is our initial state. And actually what we are doing here is nothing more than a transition, because we transition to the game placement state. And therefore, the second state we will get is then the game placement state. We just need the created state to make sure that our game is created. At least this was in the original version. I have no idea if we actually need the created state as well, because I had to have the created state in the original version because there was a lot of network from the server to the game state involved, and therefore the created state was kind of mandatory to just say the map is loaded and everything is set up, and now give me the other state around it. I don't think that we actually need it in our new game engine here for the solo game, but for now we will just leave it there, because maybe we will have a loading screen later on and then the created state can be useful. So let's just be there. I would go into the placement state. So in the placement state is now a little bit tricky. It's a little bit tricky. So what I would like, we first need to prepare the map. So let us just start the map. And then we actually get a problem, because we get trying to assign value of type node to D to variable of type in the map. Is this the map? This is the map. Get node tile factory. Why doesn't has the tile factory not the script in it anymore? Can you tell me that? I have no idea why. So completely broken here. And not saved for it. I can't understand that. That's okay. Let us just check if the other things is quite right. So let us reload it. Now we have the problem that the get texture in base null instance, because the texture component is also not loaded in the tile factory. So let us go into the tile factory, and the tile factory don't has the texture component anymore. So what is broken with my tile factory actually? Why is it? I have no idea. So we need this, and it's a texture loading component, and we need to save it, and then we have the map, and now it's working again. Okay, so I have no idea why he was missing the assignments. So the problem we have right now is that the placement is already shown, and we don't want to have the placement shown before the state is in the right state. So what I've done is I have here create the placement cells. And this I would like to delete for now. And if we are now going back into the map, we are on our first tile on the top left. And as you can see, the placement is not there. Because what we would like to have now is the placement state should be entered. And there we would like to create the placement cells. For that, we would need to have export variable map data placement. It's the map itself we need over there. So we say it's class name map to make it a little bit more defined. What we need here is the map and its type map. And then we need to call the map create placement cells on the enter function. And therefore we need also then the map data for the placement. And this is created in the map data. And here we have the map data. And we are just parsing it right here. And what we would like to do is to have the map data as a variable or map data. And then I would just say it's create placement cells on the map, create placement cells. And instead of having the placement right here, we just say map data placement, and then we wouldn't need the dictionary right here. And then we also would need to add it right here as map data placement for the key. And then we can fire it up. And as we can see, there's nothing happening. Therefore, we just set our breakpoints and say, do we get here? No, we don't get here. Then we need to find out if we get here. And I would say we don't get there. Then we need to go to our created state. And we need to see if we are going there. Just let us check if we're going here. And we fire it up. Here we are, game placement state. But we don't get into the game placement state. Why not? Caused by the state machine. We need to open the state machine script. And see if we get here. We are getting here. We have an array of 3. Which is actually the created state, which is actually the placement state, and which is actually the game state. That's pretty much it. Then we need to see if we are going here. And remove the breakpoint. We are getting here. And no, that's not the right place. We are getting here. And the old state is then the created state, and the new state name is the placement state. Therefore, we can go over it. And then he's going there and returning, because he is saying the old state is the created state, and the current state is not. And that's the problem? No, it's not. It's not null. No, it's not. It's the created state. And itself, it's initial state and current state. Old state is game created state. And the current state is null. So why he is not going there? That's the problem. Because the current state is set after the enter method. Okay, so that was the problem, and now it should work. Let us go on. Let's go on. So call to an unlisted function. That's because we are in a map, and we need to go to the placement state. And again, and again, and again. I have no idea why the export is not here. Okay, so why is the export not working? Export variable var map. Not shown over there. Hä? This is the game placement state, and we do an export there. We have a script there, this is fine. This is working with Node 2D. I'm adding the map. Now it's there. Now it's working, and it wasn't before. I have no idea. Okay, so what we need to do is to assign a map there, save it again, and shoot it up. And then he is saying invalid get index placement on null. So why is this the case? Because he's going now there too fast. Because he is going into the placement state before we actually rendered the map. So we take the create state for the creation of the map. I would say that's pretty cool. So let us go on, and we don't need the ready function for now. We take the created state, and in the create state, what I would like to do is, once we are entering, we create a map, and after the map is created, we would like to transition to the placement state. So for that, we also need to export the map as a variable, and then we need to call the map create map. Instead, I would just take the create map as a public function, and therefore we just have the create map. So let us shoot it up. And then we of course have the problem that the create map is not existing, because we need to assign the map also there again, and then we shoot it up again. And then we have the problem that a non-existent function parsed in nil, because the JSON parser is not there. Ah, okay, and that's the problem, because we are not on ready. The problem is in Godot, the children are ready before the parents. And this means that our states are executed from the child's first, even before the map is there. And if the map isn't there, we can't get the node because the nodes aren't there at this moment. So what we need to change is we need to wait for the process method of the state machine. So instead of working with the enter methods, I would like to work with the update. So on the update, I would say we have var map loaded, it's false, and we say if not map loaded, create the map and transition and emit the transition. Of course, we need to say the delta here. So if not map loaded, we create a map. Afterwards, we set the map loaded is true, and we emit the game placement state and go out of here. So let us restart it, and now everything is working expected. So what we have done now is we have just created game state, which is loaded at the beginning of the map and is actually creating our map and just saying the map is loaded. And once the map is loaded, we emit our placement state and we are going into the placement phase. And so we have also our states and the state machine working for our map, because we can now transition between the created and the placement state. And as you can see, the placement state is already handling the placements correctly. So let us just go to the codex again, and let us just see for the character states. Having a state machine inside the unit, for handling different states of the unit, we can attack, idle, move, and dash. As I said, we need to define the details later, but the initial character states are done and working. So we can close this ticket for now. We have the states for the game. The game states consisting of the placement, turn player E, turn player B. That's the problem for now. We don't have the player A or player B right now. We are just in the placement. So what I would like to do here is we just add checkboxes. We add checkboxes and say the placement state is ongoing. So we have the state machine for the game. We need some kind of component which handles the state of our game. The handler needs to be aware of what phase we are in or which player turn is right now. As soon as we have this handler, we can then implement turns with things like movement, attacking, spellcasting queue. So we have also that, and we have the state machine for the character. We can also close that. So what I would like to do next, we have two things now we can do. We have just 5 minutes left, but nevertheless, we can go on tomorrow with the states for the game and can make the placement actually happening. We could go create the enemy army and place the enemy army. So let me just reorder it a little bit. Or we could improve the viewport placement. So I would start the viewport placement for now, because maybe we can get it done in the last 5 minutes. So let me just check that one really quickly. So in a map, or better said in the placement, we have the placement cells which we had here, and in the placement cells we had the camera, which we could also put into the placement Yeah, that's a little bit a question where you would like to do it actually, but it's okay. So for the first, so what I would like to do, create placement cells. Yeah, so let me just check it out. What I would like to do is I would like to have the var min position and I would like to have a var max position, which are both a vector 2 with 0.0 and a vector 2 with 0.0. Then we set the grid cell for the cell, and afterwards I would like to have the min position is actually min from the min position itself and the cell or grid get cell get position. This is the pixel cord, and I also would like to do max position, and this is the max of the max position itself and the grid get cell get position. So this is a function call, of course, and therefore I've written this down. So what I would like to have here is to comment this out. I think we don't need it anymore. And what I would like to do here is I would like to return a dictionary with min position and with max position as a return value. And then in our placement state, we enter and we get the placement cells. And here we get the min max position from the map. And afterwards, what I would like to do here is I would like to calculate the distance. So let us say calculate how is it called? Calculate middle position, and we gave it the max min position. We have a new function which is calculate middle position. What we then need is we get the min max position, and we now need to do min max position dot min. This is a vector 2 distance to min map position max So I would like to see how this is actually work out. Is it actually working already? I have no idea. Let us just see. Invalid type in utility function. Min cannot fit more argument 1 from vector 2 to float. Vector 2 vector 2 dot float. Yeah, because let me just open the camera. It's vector 2, and for vector 2 we of course need the clamp position for the x and the y. So maybe we can use it on the vector 2. Vector 2, we have a min function, clamp min max. It's not that easy to make. I will do it tomorrow, or better in the free time, whatever. I have fun of it, but I would like to skip it for now because it takes a little bit longer. It's no problem because we can do that tomorrow. It's not too much work. We just need to get the place, the distance to it, and I will check it out later. And then I will present it to you tomorrow. I hope you had some fun today. The stream is already over again. So we did some progress with the state machine and the states for the game and the character. And I think this is quite cool. And we can work off from that. It's a good groundwork for the next steps. And I hope to see you tomorrow already on Friday. And we will, of course, go on. And I think within the next week or within the tomorrow and start of the next week, we actually can place our first units and move around with them. And then actually we can start playing the game and having more fun around it. So I'm looking forward to that, to progress through that. Maybe I can do on the weekend, maybe some art stuff. And yeah, we can try new stuff. I hope you enjoyed the stream so far. I would like to have some feedback from you guys. I would like if you join me on the stream and give me feedback, ask questions, whatever. I like to present my stuff to you, but I would like to be a little bit more engaged with the community and not just doing some kind of monologue here 2 hours long. Because I feel sad when I just have to take breaks, or I feel sad when everything is not working as I expected, and then everything is quiet here in the stream. So I would like to have more interaction with you guys. So if you like the stream or not, please give me some feedback how I can improve, how we can get you guys more involved, getting you to ask questions or whatever. What can I do for you to make it more exciting? To get more views? Is maybe the time not right? So we need to change the schedule, everything of that. If you have something in mind, please let me know on YouTube or Twitch or on my Discord server. You find the links anywhere. So I hope to hear from you. See you tomorrow, guys. Bye bye.